This is going to be the 7th grade review for Unit 5 test. I know this has been a very short unit. A lot of this is stuff that we've already covered, but we've primarily talked about similar figures and their corresponding angles, etc., etc., etc. So we're going to go and jump on into the review. Take a look at number 1. It says, which statement justifies that these two triangles are similar? Here's the thing, I really wish that I could cut and paste these images because it would allow me to do exactly what I want to, but I hope you guys remember that at one point on the board, I took a picture of a triangle, I shaded it, or not shaded it, I traced it on a piece of paper, and I was able to zoom out and I could take one triangle and overlap it onto the other. And whenever I would overlap it, you could see that the angles, like every time I would put it into one of the corners, the angles would be the exact same. So now I'm going to get rid of all this because you don't need all that, and I hope you didn't write that down on your paper. If you did, you probably weren't listening. These angles, like looking at these angles right here, I know those angles are the exact same. Congruent means the exact same, means exact same. Similar just means, or proportional and similar are kind of the same thing. It means that there's a relationship there, but they are not the exact same thing. So these two shapes, they're gonna be proportional because they are the same shape, but they are different sizes. Now the angles, like that one that I just circled, well, those are both 90-degree angles. They are congruent. They are the exact same. So I'm gonna draw a line to them and I'm gonna write same. Well, now these other corners, if I could shift the images, which I really wish I could, these are also going to be the same. And I know I keep saying corners, but I'm talking about the angles. This angle right here, that angle right there, those are also going to be the same. Now the sides, if I look at the side lengths, I'm going to go with, I don't know, we'll just take this side length right here. That side length. Well, if I compared it to this side length over here, they are not the same thing. Heck, you can look at the one on the left, it's 5, the one on the right is 10. Though they're not the same, they are still going to be proportional, mostly because it tells me that they are similar figures. Now, whenever I read through these, I'm going to go ahead and kind of summarize it. Sides are proportional, but the angles, the corresponding angles have got to be congruent. There's no difference on this. So I'm going to go through these real quick. Now I got to read it real quick. Looking in A, it says corresponding angles are proportional. We just said they are congruent. So corresponding angles are proportional. No, they have got to be congruent. So that's the big word whenever we are talking about the angles. Now the sides are not congruent. You can look at the numbers. They are not congruent. They are going to be what is called proportional. So our sides will be proportional. Sides are proportional. In fact, if I were writing notes, that is exactly what I would write down. Now, I know you guys, hopefully my folks that are actually listening to this thing, I'm very sorry that my pen is so darn clicky on this thing, but there's not much I can do about it. Now, on number 2, it says, in the drawing below, triangle GHI is similar to triangle JKL. The order of those matters. So I'm going to look at this part real quick. I need you to know that G is going to be related to J. H is going to be related to K. I is going to be related to L. Those are going to be our similar angles. In fact, here's how I want to do this. I'm going to go through and I'm going to highlight this in the exact same set of colors. So I know I just did those colors. I'm going to erase that for just a second. I'm going to start with side GH. So there's GH. Here's GH. I know that is the same thing as JK. So here is JK right here. Now for HI, I'm going to go H to I. So I'm going to use my last two letters. So I'm going to use K and L. So here's K and L. And now I've got one more color. I'm going to use, well, it's I and G this time. Or just pretty much whatever's left over. I and G. We're talking about J and L. So now I've got my 3 similar sides. Now here's what I'll be honest, I don't really like these because there are so many ways to set up proportions. This means that we have to go through each proportion and see if it's correct. Usually we do figure 1 on the left, figure 1 on the right. I'm not sure if this is how this is set up, but we got to go through and figure it out. So looking at A, it has G and H. So G and H we did in red, and GI we did in yellow. So that's both off of figure 1. So I'm going to call that shape 1. JL we did in yellow. Well, that already doesn't work. I'm going to go ahead and write KL on there too. KL we did in red. They've got the same sides. Like if I'm going side to side, these two colors have to be the same thing, and these two colors have to be the same thing. Okay? So A is out. It's not going to be A. taking a look at B. HI, we did that in blue. GH, we did in red. So we're still talking about figure 1 over here. Well, GH, we just labeled it over here. Those are diagonal from each other. That doesn't do me any good. B is out. Looking at C, we have GH, which is red. GI, which is yellow. So this is figure 1. JK is in red. And JL is in yellow. And that is figure 2. That looks really darn good to me. I'm going to double check D just in case. GI is yellow. HI is blue. And that was figure 1. JK is red. And KL is blue. See, our colors didn't line up on that one, so that didn't work out. So D is out. Our answer definitely is going to be C on number 2. Again, especially during test time, if you need colors, ask. I'm happy to give you colors during the test. Okay, number 3, no lie, out of this entire review, this is going to be my least favorite one, I guarantee it. So, let's go and get going on it. AB, I'm going to do in red. So, AB is right here. So, that's going to be similar to EF. So, I'm going to highlight EF. Next color, I'm going to do BC, which are my 2 center ones. So, I'll do FG over there. BC is going to be blue. FG will be blue. CD and GH. So, CD and GH, there's CD, GH, and then that last one, I'll just do in yellow because I've got yellow. Okay, now to go through each proportion, which, no lie, I absolutely hate this, especially whenever they repeat numbers, but I'm not seeing any repeat numbers on this one, so that's good. Nope, looking at it, I just said it, and there's a 7 that gets repeated, so that's what's going to make this a pain. Sorry, guys, I hate these. But unfortunately, we still have to go through it. So, on A, they have 5.5. Well, looking at 5.5, we did that one in yellow. So, there's 5.5. 4, the only 4 there is going to be in red. So, those are both off of figure 1. That 7, I don't know what 7 it is, so I'm going to leave that alone for a second. And 4.2. 4.2 is blue. Well, I've got 3 different colors on there. A is out. A is not going to work. Looking at B, I have a 7. Again, I'm leaving the 7s alone. 4.2 we just said was blue. That 3.4 is blue. Well, those are diagonal from each other, so that doesn't do me any good. B is out. Looking at C, we've got 5.5, which is going to be yellow. 3.4 is blue. 7 I'm going to leave alone for a second. 4.2 is also blue. So this looks pretty good so far. So the 5.5 and that 3.4 are both off of figure 1. That looks pretty darn good. Now, 4.2 is off of figure 2, and let's see if a 7 will work for us. Yep, 7 on the right, on the figure on the right is also yellow. This one looks pretty dang good. Let's check out D just in case. So the 4 is going to be red. The 7, I don't know yet. I'll figure that out in a second. The 9, what was 9 off of? That's the green one on the right. Okay, and then we have 5. Our 5 was, I'm looking for it. I'm sure it's there somewhere. Where the heck is 5? Oh, it's red. Okay, these 2 are diagonal from each other. That keeps that one from working. Our answer will definitely be C. Oh, man. I'm going to have to take a look at your test because I'm hoping the one in your test is not quite this difficult. That one wasn't too bad because they did figure 1, figure 2 for us. So hopefully that's the way it is in your test. I will check that out before tomorrow. All right, on number 4. So JT was visiting Cameron Park. At the entrance, he saw a map of the park. The legend of the map stated that 3.5 inches represents 10.5 feet. That is extremely important right there because they pretty much give us our scale right off the bat. We even know that we're going to be comparing inches and feet. So it says how many inches would represent 12 feet. Well, there's our third number. We know that we're just going to set up a WKU. And so right off the bat, we said inches and feet. And the numbers that we know, well, they gave us 3.5 inches for 10.5 feet. And our goal here is to solve for 12 feet. So I'm going to put my 12 on the bottom. So we're looking for inches. That's all we need to know. We want to know how many inches represents that. So what I would do is I'm going to cross multiply. I'm going to do 3.5 times 12. And I'm going to take that number and I'm going to divide it by 10.5. When I multiply, so I'm just going to write this out over here. So I've got 3.5 and I have to multiply it times 12. I'm cheating. Yes, I'm using a calculator. you guys won't be able to, so sorry, but I will help you guys out if you're working out the long division because I'm happy to help out with that. So then we're going to take that 42 and we have to divide it by 10.5. All we did was took that number and we divided by our lonely guy. So 3.5 times 12, then divided by the 10.5. Cross multiply, divide by the lonely guy. Now, what a lot of people get confused here, I'm going to show you how to set this up, and then I'm going to go ahead and work it out. It's top number in the box, so I'm going to take my top number, I'm going to put it in here, and bottom goes out. So we have 10.5 out here. I would highly recommend changing this thing to change both your decimals over one place. So that'd be 420 into 100 and 105. And you'll see how many times 105 will go into 420. This happens to work out really nicely because 105 goes into that 4 times. So our answer up here would be 4. Now, be very cautious whenever you guys are filling out these gridables. Our answer is 4 point nothing. That point has to be important. You do not have to put the zeros there. I'll be honest, I'm not sure about the positive. I know on our end you don't have to put the positive and fill this out, but it doesn't hurt to go ahead and do that anyways, especially if you have to do it if your answer is negative, not if it's positive, but do it anyways just to be on the safe side. And then you would bubble in your 4. You have to make sure that these are dark and neat because any scratches outside might not read properly. All right, on to the next one. All right, number 5. The ratio of the width to the length, okay, so we're talking about width to the length, of the United States flag is 6 to 21, as shown in the scale drawing below. If the width of the flag in a manual school is 3 feet, what is the length in feet? So they're giving us, they say the width is going to be 3 feet. So we're setting up another WKU. So right off the bat, we're doing width to length. They give us our scale, which is 6 to 21. And they tell us that the width of the flag is 3 feet. So we are solving for the length. So it's cross multiply, divide by the lonely guy. So you're going to do 21 times 3. And let me circle this out for you real quick. So 21 times 3. When we multiply those two, we get 63. And we're going to take that and we are going to divide it by our lonely guy. That's 6. And 63 divided by 6 is going to end up being 10.5. So again, I want to make sure that you guys know how to grid these. Our answer was positive. So I'm going to go ahead and fill in my positive here. Here's our point, and our answer was 10.5. You can include the 50 at the end if you really want to, but it doesn't matter. Make sure you circle your 1, your 0, and your 5. The other numbers do not have to be filled out. If you just feel obligated to, you got to make them zeros. All right, on to number 6. Let me read this, and then we're going to talk about it. So 6 says, triangle ABC and triangle XYZ are similar right triangles. Knowing that the right is very important. Triangle ABC has legs that measure 8 inches by 14 inches. If the longer leg of triangle XYZ measures 63 inches, what is the length of the shorter leg of triangle XYZ? Okay, a lot of letters, a lot of numbers, not a lot of sense. So let's walk our way slowly through this. Anytime they start describing stuff, for the love of all things mathy, draw them. So it tells us that triangle ABC, I'm going to do these in 2 different colors, and XYZ are right triangles. This first part doesn't have to be perfect. So here's my first triangle. Here's going to be ABC. And then here's going to be XYZ. Well, that's a terrible drawing. Hang on, let me try to fix that up. Still terrible, but we're going to go with it. So these are going to be both right triangles. And let's go with, I'm going to go ahead and label A, B, and C. I don't know what they are, but here's A, here's B, here's C. I just made that up. But now that dictates my order for the other side. So I have to do this as X, Y, and Z. Not pretty, but there they are. Now, triangle ABC has legs. So those are the 2 sides that measure 8 and 14 inches. So this one's going to be 8 inches. This one's going to be 14 inches. How did I know they were there? Well, because 8 was shorter than 14. So that's why I put them there. This says the longer leg of XYZ measures 63 inches. So our longer leg is 63. And it wants to know the length of the shorter side. So we're trying to find this thing right here. So it's just a proportion. In fact, I can do this exactly how it looks. Triangle 1, let me zoom in a little bit. I'm going to do this as 8 over 14. And this is going to be similar to our little question mark there over 63. I highly recommend simplifying first if you know how to. Otherwise, just cross multiply and divide. Just put in the hard work and it'll get the job done. So I'm going to do 8 times 63. 8 times 63, whenever I multiply those, I get 504. And now I'm going to have to divide by my lonely guy, this number right here. I can see how many times 504 can be divided by 14. And that goes in nicely 36 times. So our little number right here ended up being 36. Things that I do want to point out real quick. This number right here, well, it has to be bigger than that one there, right? Because our right triangle is the larger one. So our answer is going to be bigger than 8. 4.5 doesn't make any sense. At the very least, you got it down to a pretty solid guess. D, 110, that would be massive. Plus our number can't be bigger. So I'm trying to think how to phrase this without it looking and sounding crazy on this video. 8 is smaller than 14. So our number on the right side has to be smaller than 63. So 110 has got to be out. So our answer would be either 22 or 36, just guessing. So things I want you guys to be able to reason your way through. So you have it down to a 50-50 guess, even if you're having a difficult time with the math. But ask me how to set it up, because I'm willing to help you, especially come test time. To a point. You got to ask good questions, of course. Number 7. For an activity in class, students use pieces of string to measure roads on a map. They use a map scale to determine the distance between two cities. So we know we're talking about a scale. One group measured the distance between Fort Gordon and Mississippi State on a map. The string distance was 3.75 inches, which represents a real-life distance of about 136 miles. It didn't come out and say it explicitly, but this is our scale. So it says it represents. Represents is kind of like our ratio. That 3.75 inches is going to be a real-life distance of 136 miles. Another group measured the distance between Dallas and Austin and found the distance to be 6.75 inches. What is the real-life distance to the nearest mile between Dallas and Austin? So we're doing an inches and miles conversion. They're going to give us inches. We're going to find actual miles. So we're doing inches to miles. And our scale, they told us that it's 3.75 inches. Is 136 real-life miles. So that group, they measure their distance on their little map between Dallas and Austin of 6.75 inches. Well, that goes up top with our inches. And what we want to know is that distance right there, the actual distance between Dallas and Austin in miles. So again, it's cross-multiply, divide by the lonely guy. No lie, these numbers are pretty rough. So they're going to have some work to put in on this one. So I'm going to do 136, and I'm going to multiply it by 6.75. Whenever I multiply those, I get 918, and I still have to divide by that 3.75. Just some reasoning skills will be able to, actually looking at your answer choices, no, these aren't going to be able to be knocked out easily, so you're going to have to put the work in on this one. I would highly recommend shifting decimals on both of these. I would shift this over 2 places, and I would add 2 zeros here. So really what you're doing is you're doing 91800 divided by 375. So that one's pretty rough. Hopefully it looks like you're only going to go out to 1 decimal place just looking at your answers. So I'm going to do this in the calculator real quick because we got to get this done. And this comes out to 244.8. So our answer choice would be C. Things that I could do just to try to make my life a little bit easier, I could take this 375 and multiply it by each of these answers and see which one would give me that that 91,800. I could reverse it. If I'm not good at doing the long division, try to work backwards instead. All right, on to number 8. Things that I would write down, as far as notes go. This is supposed to make a right triangle right here. And it is also supposed to make a right triangle over here on this side. It's tough to tell because they got the big old tree in the way. That 40 degrees, while it does matter that they're both 40 degrees, for our purposes, it's not going to matter this time around. So number 8 says Evan and Hayden were trimming the branches off of a tree. Evan was using a 16-foot ladder, and Hayden was using a 28-foot ladder. Both ladders were leaning against the tree at a 40-degree angle. Again, for our purposes this time around, we don't need the 40 degrees. The bottom of the 16-foot ladder was 6 feet away from the tree. What is D, the distance the taller ladder is from the tree, measured in feet and inches? All right, so here's the thing about the and inches. We're not doing an inch to feet comparison. Looking at these, what we're doing is we're doing one side of the triangle compared to, actually I shouldn't have done that in red. We're gonna do this in yellow. We're doing the yellow sides because those are our similar sides, and we are going to compare them to our green sides because that's the color that I chose to use this time around. Okay, we're doing a comparison of yellow to green. Really and truly what it is, it's hypotenuse to leg if you really want to lay it out like that. We're just solving for D right here. So what I'm going to do, I've got figure 1 here, I've got figure 2 here. I'm going to do my comparison. I'm going to do yellow over green. All right, so on my figure 1, my yellow is 16, my green is 6. On the right side, my yellow is going to be 28, and my green is going to be D. So again, I'm going to cross multiply, and I'm going to divide by the lonely guy. So I'm going to do 6 times 28, and I get 168. And I have to divide that by my lonely guy, by 16. And whenever I divide those, I get a nice even 10.5. Now looking at my answer choices, they didn't actually do this one in inches, which is nice. What I want to point out is that 0.5, that's 1/2 of a foot. That would be like 10 feet and 6 inches. That's the same. In fact, I want you to write that out on here. That's 10 feet, 6 inches. Because on your test, your answer is not going to be in decimal form. They're going to say 10 feet, 6 inches instead. But all I really need to know is that 10, because look at the answer choices. None of the other answer choices have 10 at the beginning. So just so you guys are aware of that. All right, on to number 9. Carolyn enlarged a drawing she made in art class. What is the value of x? Round to the nearest tenth. This is just setting up a proportion. No, not too big a deal on this. If you want to use colors, there's not a darn thing wrong with using colors. So I'm going to use blue, and I'm going to use red, because for some reason I keep using blue and red. So, figure 1, if I'm setting up a proportion, setting up line equals line, I'm going to do that in black. Line equals line. On the left side, my blue, actually, I'm going to do this again, sorry. I'm going to do this as blue to red. And there are other ways to set this up. If you are familiar with one of the other ways that we've done it, perfectly fine. This is just the way it crossed my mind to do this one first. So, blue on figure 1 is 3.5. Red on figure 1 is 4.75. Blue on my figure on the right, or on figure 2, is x. And red on the right is going to be 50. So now I'm just going to cross multiply and divide. So I'm going to do 50 times my 3.5, and I get 175. And now I have to divide by my leftover number, that 4.75. And when I divide that by 4.75, I get a really gross number, like a really gross number. Well, I did say round to the nearest tenth, so that's good to know. So I end up getting 36.8, which happens to be that one. Again, things that I just want to point out real quick. Looking at your answer choices compared to what we've got here. I know this is kind of hard to see because I've got a bunch of scribble on there already. But this 50, compared to my x right here, well, x, looking at the figure over here, blue is smaller than red. So looking here, blue has to be smaller than that 50. So my answer's got to be less than 50. So if I was just trying to reason my way through this, I could knock out B and D right off the bat. Unfortunately, A and C are unreasonably close to each other, so that's where you've got to work it out and know how to round. All right, final one. Number 10. Kylie was looking at the architect's blueprints of for her house. She knows the dimensions of her bedroom are to be 20 feet by 24 feet. The scale on the blueprint of the house is 1/4 inch equals 1 foot. What are the blueprint dimensions for her bedroom? All right, this is some pretty good real-world stuff, just so you guys know. I want you to be aware of that. Things I want to point out real quick. before we even bother doing this, because you guys have done one similar to this before. If I solve for the shorter length of her house, and this is the, not of her house, of her bedroom, the shorter length, and that's the longer length, well, it's going to be like solving for either the 7 inches or the 8 inches here. Same thing here. Blue, red. Same thing on all of these. Blue, red. All of these numbers, the first number on every one of these is different. We've got 7 inches, 5 inches, 80 inches, 9 inches. If I just use this one to solve for, that's all I have to do, and then I would be done. I don't really have to use that 24 feet. I'm not worried about that second number on there. I can do one thing to solve for. That will save me a ton of trouble. So we're going to be doing inches to feet. They give us our ratio right here. I would definitely change this to a decimal number. I'm going to call that 0.25 because I think that's going to be easier to work with this time around. So my ratio, like I said, we're doing inches to feet. I love WKUs. I don't know if you guys probably hate them by now, but they work for everything. I can only begin to tell you like the careers that you would use a WKU in. So anyways, so we've got inches and feet. We just said 0.25 inches is equal to 1 foot. And what we want to know is how many inches her bedroom is going to be on the scale drawing. So it tells us that her bedroom is going to be 20 feet by something or another, and the other part doesn't matter. So I'm going to here's what I'm doing. I'm taking that 20 feet over here that I circled, and I'm putting it right here, because we want to know how many inches that's going to be on the drawing. So I'm going to do my cross multiply divide gig. Let me change colors real quick so this doesn't blend in. So I'm going to do 0.25 times 20. So let me do that in the calculator real quick. Oh, actually, that's not too bad if you actually think about it. Anyways, so 0.25 times 20 is 5. Then I have to do, so I got 5 there, and I'm going to do 5 divided by 1, which is just 5. So x is going to be 5. So that on the scale drawing, her bedroom's going to be 5 inches long. So our answer is going to be B on number 10. Guys, if you have questions, please ask. I hope you've been using this review to set up your little paper cheat sheet for the actual test, because you guys will get to do that this time around. As long as it's handwritten and done by you, you guys will get to use that thing.